Hello, Assalamualaikum friends. This is Muhammad Inam, and in this video we are going to talk about the Boyle law. And this video is especially for students of school and high school. So, contents of the video is a statement, animation, how Boyle's law work, and examples about it. So, the first of all, the statement of Boyle's law: the volume of a given gas is inversely proportional to pressure at constant temperature. Um, The statement of Boyle's law is very simple. If the volume is inversely proportional to pressure, it means if pressure is increases, the volume must be decreased, and if pressure decreases, the volume must be increased. So here is the animation. You can see that this is the gas cylinder and this is the volume scale, and these are the meter for pressure and temperature, and this is graph that shows the relation between volume and pressure. So the pressure is increased or decreased, so you can see that how volume is increased or decreased at constant temperature, and the graph shows the concave down means inverse proportionality. So here we can say it a mathematical relationship for Boyle's law that should be the volume is inversely proportional to pressure, and if we remove the proportionality sign, we have constant, which is k. And in other words, we can say that PV or Vp equals to k. And this is another statement for Boyle's law, that product of pressure and volume must be constant. And this is another way to use the Boyle's law. We can say that this is the before situation, means the pressure 1, say P1, and then volume 1, and this is after situation. Here we have pressure 2 and volume 2. So we can see that the same at constant temperature. In both cases the temperature is same, and we have used the same gas here, but with different pressure we have different volumes. So we can create also the relationship for this before and after situation. We can say that the V1 P1 equals to K. Similarly, and V2 P2 equals to K. By mathematical proportional equality, we can write it like P1 V1 equals to V2 P2, and this relationship we can use for the before and after situation. So here is one example of the pressure of a sample gas is 3 atm. Atm is the unit of pressure, and the volume is 5 liter. If the pressure is reduced to 2 atm, what will be the new volume? So we can see that the pressure is decreased. So according to Boyle's law, volume must be increased. So let's first of all we have data. The pressure is 3 atm, and the volume is 5 liter, and this after pressure is 2 atm. We need to find the new volume. So by Boyle's law, P1 V1 equals to P2 V2, and we need to find the volume too. So the relationship should be this one. Here we need to just plug in the values, where P1 is 3 and V1 is 5 and P2 is 2, and this is 7.5. It means the new volume is 7.5 liter, and this is true because the volume is decreased, so volume pressure is decreased, so volume is increased. Before we have 5 liter volume, and now we have 7.5 liter volume. Another example, the 700 centimeter cube of a gas is enclosed in a container under a pressure of 650 millimeter of mercury. This is another unit of pressure. If the volume is reduced to 350 centimeter cube, what will be the pressure then? So first of all, write it data. The volume 1 is 700 centimeter cube, and then we have the pressure, which is 650, millimeter mercury, and the new volume is 350 centimeter cube. We need to find the pressure. So according to relationship P1 V1 equals to P2 V2. We need to find P2, so this will be like P1 V1 and V2 equals to P2. Now just plug in the values, that is 700 times pressure 1, that is 650, and divide by the new volume, that is 350, and this is 350 times 2, and 2 times 650, it's 1300 millimeter mercury.